Good morning, everyone. Welcome to Knowledge Point by Amit Bagrecha YouTube channel. In this video, we will be talking about a very classic data structure problem named Tower of Hanoi. So, many of us know that what is the Tower of Hanoi problem, and we also know about two ways of writing the program to solve this problem. One is recursive and second one is नॉन रिकर्सिव। तो टावर ऑफ हनोई प्रॉब्लम को सोल्व करने के लिए हम लोग दो तरह से प्रोग्राम लिखते हैं। पहला प्रोग्राम है कि हम लोग रिकर्जन के थ्रू इस प्रॉब्लम को सोल्व करते हैं, और दूसरे तरीके के अंदर हम लोग जो प्रोग्राम लिखते हैं उसमें हम लोग बिना रिकर्जन के मतलब लूपिंग के थ्रू हम लोग टावर ऑफ हनोई प्रॉब्लम को सोल्व करते हैं। ओके, तो इस वीडियो में हम लोग देखेंगे कि अगर हम लोग टावर ऑफ हनोई के लिए रिकर्जन के थ्रू प्रोग्राम लिखते हैं तो वो प्रोग्राम स्टेप बाय स्टेप किस तरह से एग्जीक्यूट होता है और किस तरह से हम लोगों को मूव की सीक्वेंस मिलती है। सारे डिस्क को टावर ए से टावर सी पर मूव करने के अंदर क्या क्या स्टेप्स होती है और वो स्टेप की सीक्वेंस में होती है, वो हम लोग देखेंगे कि जब हम लोग रिकर्जन से इस प्रोग्राम को सोल्व करते हैं देन किस तरह से क्या क्या स्टेप्स हम लोग परफॉर्म करते हैं, एंड अल्टीमेटली सारी डिस्क टावर ए से टावर सी पर मूव होती है इन द सेम ऑर्डर जिस ऑर्डर में वो आपकी टावर ए पर रखी हुई थी। और कितने नंबर ऑफ मूव्स होंगे, अगर हम लोगों को n नंबर ऑफ डिस्क गिवन है तो कितने हम लोग टोटल मूव काम में लेंगे कि सारी डिस्क टावर ए से टावर सी पर मूव हो जाए, जहां पर टावर ए is the source and tower C is the destination and tower B is a temporary tower for helping us to move the disk from tower A to tower C. Okay, so in this diagram we have three disks, so n equal to 3, and the disks are placed on tower A in the descending order of their size. So smallest disk is at the top and the largest disk is at the bottom. Okay, so what we are doing in step number 1, move the topmost disk. Let's say we have disk number 1, 2 and 3. Okay, so move disk number 1 from tower A to tower C. This is step number 1. Then move disk number 2 from tower A to tower B. Then move disk number 3 from tower C to tower B. Then move disk number 3 from tower A to tower C. Okay. Then move disk number 1 from tower B to tower A. Then move disk number 2 from tower B to tower C. And finally move disk number 1 from tower A to tower C. So it took total 7 steps. So if we have to move 3 disks, we have to use 7 steps to move all the disks from tower A to tower C. So how many moves will be required? The total number of moves will be 2 power n minus 1. So in case of n equal to 3, what number of moves we will get? 2 power 3 minus 1 equal to 8 minus 1 equal to 7. We will need total 7 moves. Okay, and one very interesting fact that the 2 power n by 2 step In this step, we will move the largest disk from tower A to tower C. So here you can see in step number 4, we moved the largest disk, which was disk number 3, from tower A to tower C. And if there are total 4 disks, say if we have n equal to 4, then total steps will be 2 power 4 minus 1 equal to 16 minus 1 equal to 15. So total 15 moves will be needed, and 2 power 4 divided by 2 equal to 16 by 2 equal to 8th step will move the largest disk from tower A to tower C. Okay, now move further. So what is the logic to solve this Tower of Hanoi problem? So the logic is very simple. Move n minus 1 disk or n minus 1 rings from tower or pole A to pole B using pole C. Okay, n minus 1. So what we have to do? We have to first move n minus 1 disk or n minus 1 rings from tower A or pole A to pole B using pole C as a helper pole or using a temporary pole. Okay. Then there will be only one ring or one disk remaining on pole A. So directly move that disk or that ring from pole A to pole C, and then move n minus 1 disk or n minus 1 rings from pole B to pole C using pole A as an intermediate or as an helper pole or helper tower. Okay, and how many total number of moves will be required? I have already explained, 2 power n minus 1. Okay, so let us say we have n equal to 1. We have only one disk. Okay, so tower A, tower B or tower C, and we can say pole A, pole B and pole C, A, B and C, and we have only one disk. So move n minus 1. So n minus 1 will be 0. So no need to move any disk to pole B. Okay, then move the one ring. So here is only one ring on pole A. So move this to pole C. Okay, so move this to pole C. Okay, now there is no ring on pole A. Move n minus 1 rings from pole B to pole C. N minus 1 means again 0. So no need to move any disk from pole B to pole C with the help of pole A. Okay, so only one move is needed. And if we check from formula, so it will be 2 power 1 minus 1 equal to 2 minus 1 equal to 1. So what happened? 1 will be the answer. Only one move will be needed. If we have n equal to 2, then what will happen? So disk 1 and disk 2, pole A, pole B and pole C. Move n minus 1 rings from pole A to pole B using pole C. Okay, so n minus 1. So n minus 1, so n is 2. So n minus 1 means what? 1. So move this 1 ring from pole A to pole B. So put it here. Move the one ring left on pole A to pole C. So now on pole A there is only one ring, the bottom one. So directly put this ring from pole A to pole C. Then move n minus 1 rings from pole B to pole C using pole A. So n minus 1, again n is 2, so n minus 1 equal to 1. So move this ring from pole B to pole C. Okay, so how many iterations we needed? 2 power 2 minus 1 equal to 4 minus 1 equal to 3. So in 3 moves we moved the disks from pole A to pole C. Okay, so this is the concept, or this is the logic to make the things happen. Now we will look at the program and we will solve, or we will understand that program step by step, that actually what is going on, how the recursion is working, and how the disks are ultimately moved from tower A or pole A to pole C in the same order which was on tower A. So here is the C program, and this is the function which is doing all the task. Only these 4 or 5 lines of code which is making it happen. So we have included the header file, and now this is the function definition. Name of function is TOH. N means number of disk or number of rings. Source means the source tower. Destination means destination tower or destination pole. Temp means a temporary tower or helper tower from whose help we are making the moves. If n equal to 1, if there is only one disk or one ring, then move disk 1 from source pole to the destination pole. Okay, then we are again calling the same function with n minus 1 rings, with n minus 1 rings. So n minus 1 source, temp and destination. Move n minus 1 rings from the source tower to the temporary tower with the help of destination tower. So if source is A, temp is B, and destination is C, then what we are doing as per the logic, move n minus 1 disk from tower A to tower B using tower C. Okay, then move disk. So there will be only one disk remaining on tower A. So move that disk from tower A to tower C. Okay, and then move n minus 1 disk from tower B to tower C using tower A. So the logic which we discussed few moments ago, we are actually putting that logic into a code. Okay, and this is the main function. Int number of disk, how many number of disk you want to play with, so that is will be inputted in number of disk. So scanf m% number of disk, so whatever number of disk you want, but its value should be greater than 0. Okay, and then we are calling the function Tower of Hanoi. Number of disk, A is the source, C is the destination, and B is the temporary or helper tower or helper pole. Okay, so we looked at the code. Now how these functions is calling itself and how the moves are happening, we will see it with the help of diagrams, that how this code is working and how ultimately all the disks are moved from tower A to tower C in the same order or in the descending order of the disk. So largest disk will be at the bottom and smallest disk will be at the top. Okay, so let's start with, let's say n equal to 1. So we have only one disk. we have only one disk. So A, B and C, and this is only one disk, so this is disk number 1. From main method, from the main function, this function will be called. This function will be called. Okay, and number of disks are 1. Number of disks are 1. So the function call will be TOH1 A, C and B. This is the function call. So when a function is called, the control is transferred to the function definition. So we will jump on to the function definition. So the value will be of this actual parameter will be copied in the formal parameters. Okay. So TOH1, what is the source? What is the source? A. So A, what is the destination? C, and what is temp? B. If n equal to 1, n, so n equal to 1, so condition is satisfied. The printf statement will be executed. Move disk 1 from pole %c to pole %c source comma destination. So source is A, so from pole A to destination is C, so pole C. Disk 1, move it from pole A to pole C, and then we are still in the scope of if condition, and return. Return means the function will return. So where it will return? From where it was called. जहाँ से function call हुआ था वहां पे वापस return हो जाएगा. तो ये कहाँ से call हुआ था आपका? It was called from the main method. Okay, so it will return back. It will return back to the next statement. So what is the next statement? Closing curly braces. What is the next statement? Closing curly braces. So program will terminate. So what will be the output? Move disk 1 from pole A to pole C. So directly put this disk on pole C and the job is done. Okay, so this was when we were having n equal to 1. Okay, now we will see when n equal to 2 how it will work, and when n equal to 3 then how the logic will work. Okay, so let me erase, and then we will see for n equal to 2 and then n equal to 3. Okay, so let's say now we have n equal to 2. Okay, so pole A, pole B and pole C, disk 1 and disk 2. Okay, so the execution begins from the main. So number of disks are 2. Number of disks are 2. TOH from the main, this function will be called. So what will be the function called? TOH to A, C and B, and this function call will take the control to the function definition. So what will be the function definition? Void TOH, n is 2, source is A, destination is C, temp is B, and the opening curly braces. If n equal to 1, n equal to 1, but what is n? 2. So the if condition will be false. So we will move further in the function definition. Then we will move to TOH n minus 1, so 2 minus 1, 1. Source is what? A. Temp is what? B. And destination is what? C. Semicolon. So this is again, it will call the same function again. Okay, we will just see in a bit that how it will call. Then we will have a printf statement, and then we will have again TOH n minus 1, so n is 2, so 1. Temp is B, dest is C, and source is A. So it will again make a function call, and we are have the closing curly braces. Okay, now coming on to this is a function call. This is a function call, so it will again call the same function. Okay, so what will happen? It will be TOH 1 A B C, and then the function definition. So 1. If n equal to 1, yes, n is 1, then we will come into the scope of if statement. Move disk 1 from pole %c to pole %c source comma destination. So source is A and destination is B. From pole A to pole B. Move disk 1 from pole A to pole B, and then we have the return statement. Return statement means from where the function was called, take the control to the next statement from where the function was called. So from where this function was called, it was called from here. So we are returning, and now we are at the printf. Okay, so move disk 1 from pole A to pole B, we get this move. Now we are at the printf statement. Okay, of this function. What it says, move disk 1 from pole, move disk %d from pole %c to %c, and n comma source comma destination. Okay, so move disk n is what? 2. So disk 2 from source to destination. What is source? A. So pole A to, and what is the destination? C. What is the destination? C. So from pole A to pole C. Move disk 2 from pole A to pole C. This is the second move. Okay, then we come here again, function call. Okay, so when the function is called, we will again move on to the function definition. Same function. Okay, what is that? Let me space is very less. So look, I am writing here TOH 1 B C A. If n equal to 1, so n is 1. Printf move disk 1 from source to destination. So what is source? B. And what is destination? C. Move disk 1 from pole B to pole C. This is the third move. Okay, and then we have the return statement. So from where the function was called, we have to return there. So this function was called from here, and here we have the closing curly braces. Okay, so we return, and when this closing curly braces come, from where this function was called, this TOH to ABC, from where it was called? It was called from the main method. Main method means it was called from here, so we will return again here the next statement after this function call, which is the closing curly braces of the main function. So the program terminates and we get the output. So what is the output? Move disk 1 from pole B. Move disk 1 from pole A to pole B. Move this from pole A to pole B. Then what was the second step? This one. Move disk 2 from pole A to pole C. Move this one from pole A to pole C. And what is the third move? Move disk 1 from pole B to pole C. Move this one from pole B to pole C. And we are done. Okay, so in this way the recursion happen. Okay, now if we have n equal to 3, then what will happen? So kindly follow with me and understand it very properly, and if you have any doubt, then mention in the comment. Solve it using pen and your notebook. You will enjoy solving this kind of problems. So let me erase, and then we will see for n equal to 3 that how these recursive functions are working when we have 3 disks. Okay. So now we have n equal to 3. We have 3 disks. So we have n equal to 3. So this is pole A, pole B and pole C. Disk 1, disk 2 and disk 3. Okay. So number of disks are 3. So the function will be called from the main. Okay. And it will take us onto the function definition. Okay. So int n is 3, source is A, destination is C, and temp is B. If n equal to 1, then do this. Otherwise we will move here because the n is not equal to 1, so we will come here. So what will happen? It will say TOH n minus 1 2, source is A, temp is B, and dest is C. Then this printf statement will execute, and then it will again call itself TOH 2, temp is B, dest is C, and source is A. And then it will have the closing curly braces, and then when everything completes, the function will return back to the main method, and we will encounter the closing curly braces of the main method. Okay, now we are here. So it is again calling itself. Okay, so what will happen? TOH 2 A B C and the opening curly braces. If n equal to 1, then move the print, then print the move, but n is not 1, so we will again come to the TOH n minus 1, so 2 minus 1 1, source is A, temp is C, and dest is B. Then we will have a printf statement. and then again we will have a recursive function called TOH n minus 1, so 2 minus 1 1 temp is, what is temp? C. Next is B, source is A, and we have the closing curly braces. Okay, we are talking about this one, we are talking about this function, not this. Okay, so we are here now. It is again a recursive call. It is again a recursive call. Okay, so it will call itself again. So what will we have? TOH 1 A C and B. Now according to the function call, if n equal to 1, so yes, we have n1, print f move disk 1 from source to destination. So disk 1, move it from source A to C, and return means from where this function was called, return back to there. So this function was called from here. Okay, so return to the next step from where the function was called. So we will return on to the printf statement. So this is the first move. This is the first move. Move disk 1 from A to C. Disk 1 A to C. Okay, this one. This we have to move from A to C. Then we are here. Printf move disk %d from pole %c to pole %c source comma destination. So move disk number n from source to destination. So what is n here? 2. So move disk 2 from, what is source? A, and what is destination here? B. So A to B. Move disk 2 from A to B. Move disk 2 from A to B. Okay, then we will again have the function call. We again have the function call. Okay, so what will happen? It will be TOH 1 C B and A. So as per the function definition, if n equal to 1, yes, n is 1, move disk 1 from source to destination. What is source here? C. And what is destination? B. C to B. Move disk 1 from C to B. So move disk 1 from C to B. So this is, and then return. So we return. So from where the function was called, we will return there in the next statement. So we have the closing curly braces. Okay. So this is the closing curly braces from where this function was called. This function was called from here. So we will move on to the next statement. Okay, what is the next statement? This printf. So what it will say? Move disk n from source to destination. Move disk %d. What is value of %d? N. Move disk n from source to destination. So disk n for this function, what is n? 3. So move disk 3 from, what is the source for this function? A, and what is the destination? C. So disk 3, move disk number 3 from A to C. From A to C, this is the fourth step. So move disk 3 from A to C. Okay, then we have this function call again. TOH 2 B C A. Again this function will call itself. Okay, so let me erase this one, and then we will see this recursive function call. Okay, so now we are on to this function call. So what is says TOH to BCA. Okay, as per the function definition, if n equal to 1, then make the printf return, otherwise call the function again. So n is not 1. What is n? N is 2. So if condition will fail, so we will move further in the function definition. So what it will say TOH n minus 1. So n minus 1, 2 minus 1, 1. Source. What is source? B. Temp. What is temp? A. And what is destination? C. Okay, then printf move disk %d from source to destination. So we will have the printf statement. And then what is the next statement? Again the function call TOH n minus 1, 2 minus 1, 1. Temp. What is temp? C. Dest. What is temp? Temp is A. Sorry. What is dest? C. And what is source? B. Okay, this function will call. Now this function call. Okay, so what it will do? TOH 1, B, A and C. If n equal to 1, yes, n is 1, move disk 1 from source to destination. What is source? B. And what is destination? A. So move disk 1 from B to A. Disk 1 B to A. Okay, and then we encounter the return statement. So return means from where this function was called, take the control to the next statement after the function call. So we will move on to the printf. We will move on to the printf. Okay, I am erasing this one. So printf move disk %d from source to destination. And what is the value of the %d? N. So move disk 2, n is 2, move disk 2 from source. What is source? B. To destination. What is destination? C. Move disk 2 from B to C. Move disk 2 from B to C. Okay, then we will come on this line. So again the recursive function call. Okay, so what will happen? It will write TOH 1 A, C and B. If n equal to 1, yes, n is 1. So we will come into the scope of if statement. Move disk 1 from pole source to pole destination. So what is source? A. What is destination? C. From pole A to pole C. Okay, from pole A to pole C. Okay, so disk 1 A to C. Okay, then return. We encounter the return statement. So from where the function was called, we will move back to next statement after that line. So we will come on to this closing curly braces. Okay, so this function call is done. This is done. So we will move back from where this function was called. This was called from here. So we will move on to the next line after this statement. So we will come on to here where this one, this closing curly braces of this function. Okay, this 3abc, the call was TOH 3abc, and from where this function was called? This was called from the main. So we will move back to the next line after this function call from the main. So where we are moving, we are going to the closing curly braces of the main function. So the program terminates and we get the output. So what is the output? These are the sequence of moves we get in the output. Okay, so let's check that are we getting the correct output or not. So let me erase this and quickly check this output, that are we doing it in the right way or are we making any mistake. Okay, this was the whole sequence of moves using this recursive call. Okay, we let me erase this and just a bit and let us check. One, 2 and 3. This is pole A, pole B and pole C. Okay, move disk 1 from pole A to pole C. Move it here. So we have the disk 1 here. Then move disk 2 from pole A to pole B. Move this from here to here. Disk 2. Then move disk 1 from pole C to pole B. Move this from here to here. So now it is empty. Then move disk 3 from A to C. Move this one from here to here. Disk number 3. Okay. Move disk 1 from pole B to pole A. Here it is empty. Move disk 1 from pole B to pole A. So this from here to here. Okay. So I am making it here. Disk 1 from pole B to pole A. Then move disk 2 from pole B to pole C. This is disk number 2. So move it to pole B to C. So this is disk number 2. So disk number 3 and above it disk number 2. Then move disk 1 from pole A to pole C. Move disk 1, this one from pole A to pole C, and we have moved all the disk in the increasing order of the size from top to bottom, from pole A to pole C, and it took 7 steps. It took 7 steps. So if you look at step number 4, in this step we are moving the largest disk from tower A or pole A to pole C. Okay, so before it we are doing the job of moving n-1 disk from A to B. Then we are moving largest disk from A to C, and then we are moving n-1 disk from pole B to pole C using pole A. And this was what we discussed in the logic, and this is the proper explanation, or this is the step-by-step explanation of the recursive method of Tower of Hanoi for 1 disk, 2 disks and 3 disks. If you have 4 disks, 5 disks, 6 disks, whatever number of disks you have, you can solve, or you can understand, or you can explain yourself step by step that how this entire logic is working. So this was it for this video. I hope you have learned, or you have understood that how the recursive method of Tower of Hanoi problem works step by step. And if you have any doubt, then mention in the comment. And if you really got some knowledge, if you really got how to make the logic and how to see that logic in the action, then kindly comment in the video, like the video, and if you really adding some value to your knowledge from this video, then kindly subscribe to this channel, because on this channel such knowledgeable and such informative videos are published almost every day. So subscribe to this channel and enhance or polish your knowledge. So see you in the next video. Till then, bye bye.